Two posts this week point to the same quiet move. Teams are tightening control before they push harder on scale. I'm Nick. This is your AI brief for June 25th, 2026. Let's get into it. Today, two stories show it clearly. One is OpenAI, the model company, building its first custom chip with Broadcom, the semiconductor vendor. The other is LangChain, the agent framework team, writing about memory for agents. On the hardware side, OpenAI's chip write-up, the clearest cost signal, serving economics are starting to shape roadmap choices. The point is simple. If inference is expensive, you look for tighter control over the stack. OpenAI is moving into custom inference silicon with Jalapeño. The aim is to cut cost, reduce Nvidia dependence, and couple hardware more closely to software. That says future serving work may split between flexible GPUs and more specialized paths. Meanwhile, LangChain's memory piece, the clearest runtime control case, agent teams are treating memory as system state, not a prompt trick. The pattern is explicit loops. Capture traces, analyze them, then write durable context back. LangChain lays out that loop in practical terms. That matters because agent behavior gets easier to debug when memory becomes part of the runtime, with a known place to inspect and update state. The shared thread is small and plain. Both teams spent effort on control surfaces before chasing more scale. That might be a pattern or just these two posts this week. Today's two stories both point downward in the stack. One is about serving costs and hardware. The other is about agent behavior at runtime. First up, OpenAI, the model company, and Broadcom, the semiconductor vendor, on OpenAI's first custom chip. It's a clean example of inference economics shaping roadmap choices. Then we switch to LangChain, the agent framework team, and its memory write-up. That one is about making control explicit inside the agent loop, not hiding it in prompts. On the hardware side, OpenAI's chip write-up, the clearest cost signal, inference economics are starting to shape roadmap choices. The basic point is simple. If serving gets expensive, teams start looking for tighter control over the stack. OpenAI is moving into custom inference silicon with Jalapeño, built with Broadcom, the semiconductor vendor. The goal is to cut cost and reduce dependence on Nvidia. It also tightens the hardware-software loop. That matters for practitioners because roadmap choices start to split. Some workloads still need flexible GPUs. Others can justify specialized hardware or narrower serving constraints. That's a different kind of optimization work. Meanwhile, LangChain's memory piece, the clearest runtime control case, agent teams are treating memory as system state. The pattern is explicit loops, capture traces, analyze them, then write durable context back into the agent. LangChain lays that out in practical terms. Memory stops being a prompt trick and becomes part of the runtime. That helps with debugging and with behavior. You get a known place to inspect state and update it. It also changes where teams spend effort. Instead of polishing prompts alone, they build a place for durable context. That is the practical shift here. Serving cost on one side, runtime control on the other. If there is a shared thread, it is small. Both teams are spending effort on control surfaces before chasing more scale. Might be a pattern, might just be these two posts this week. If there is a thread, it is small. Both stories put effort into control, not just capability. That is the practical read, and I would keep it narrow. We're looking at two posts, not the whole field. On one side, OpenAI is pushing on serving cost. It is moving toward custom inference silicon with Jalapeño. That matters because it shows roadmap choices getting tied to economics. Some workloads can stay on flexible GPUs. Others may justify specialized hardware and tighter serving rules. That is not a model story anymore. On the other side, LangChain is doing the same kind of work at runtime. Its memory piece treats context as system state. The pattern is simple. Capture traces, analyze them, then write durable context back into the agent. That gives teams a clearer place to inspect behavior. It also makes debugging less of a prompt hunt. So the shared move is not flashy. It is control surfaces getting more attention as systems head toward production. Cost, memory, and governance keep showing up in that work. Worth watching. That is the modest takeaway from today. Small sample, small claim. That's your brief. Links and full analysis in the newsletter. See you tomorrow.